So good morning, everyone, and welcome to the lecture. This is lecture number 10, and we are dealing with the relation between conservative force and potential energy. And I guess in the last class, we had seen how we can find out how we can find out the change in energy or the difference in energy if force is given to us. And we had seen this relation U2 minus U1 is negative of F dot dr. Oops. Do we remember this relation? Relation number 1. Yes or no? Okay. Then that was, if you have force, how will you find out the change in energy? The second example, we had seen how we can find out force when the energy function is given. And this del by del x or del by del y or del by del z comes into the picture here. What is this del? Any idea? What is this del? This del is known as, it's a mathematical operator. This del is known as, partial derivative. Now, what do you mean by partial derivative? This del is known as a partial derivative. Partial derivative with respect to x. So, if you have del by del x, it is known as partial derivative. Then we have something known as the complete derivative or the full derivative or the derivative, simply derivative. That is your d by dx. That is the complete derivative. Now, what do you mean by partial derivative is that when we are having this partial derivative, for example, this is partial derivative with respect to x. Only x is treated as the variable. Rest everything is treated as a constant. So that is how we understand partial derivative. Only x is the variable quantity. We only vary x and we keep everything as constant. So even if they are y and z will be treated as constants. But when we have complete derivative d by dx, whether there is x or y or z, everything would be treated as a variable. What difference does it make? What difference does it make in mathematical thing? Just try to give you an example. Have you noted this down? We'll try to give you an example. For example, if I have a question, find the derivative of 3x square. What is the derivative of 3x square? The derivative of 3x square is
6x.
x. If I now ask you what is the partial derivative of 3x square? The partial derivative of 3x square is also 6x. X is already there. X is the variable. In the first equation also x is the variable. Partial derivative of 3x square with respect to x is 6x. If I say that the partial derivative of y cube, I'm now differentiating with respect to y. Complete derivative of y square, that is 2y. Partial derivative of y square, Well, that will also be equal to 2y. So from here it seems like they are same. What is the difference? There is a difference. Now, if I have an example where I have to find out the complete derivative of x square plus y, the complete derivative of x square plus y will be equal to, I will have to differentiate x square, that will be dx, and then I will have to differentiate y also because y is the variable. So I will write it as plus dy by dx. That is the complete derivative of x square plus y. But when I find the partial derivative of the same thing, what is the partial derivative of this? Y will be treated as a constant and derivative of a constant is 0. So the complete derivative of this thing is 2x plus dy by dx, but the partial derivative is only 2x because y is a constant. That is the difference between a complete derivative and partial derivative. One more example. If I take the complete derivative of x into y, if I take it complete derivative of x into y, then I have to use the multiplication rule. So first, I will differentiate x, derivative of x is 1, and I will multiply it by y, plus, then I will multiply x by the derivative of y. So this will be the complete derivative. Do you understand what I have done here? This is the complete derivative of xy. I have used the multiplication rule here. Multiplication of one function into the second function. But on the other hand, if I take the partial derivative of xy, y is a constant. The partial derivative of xy becomes simply y. Do you understand this? Partial derivative in that way is simpler than the complete derivative. If I find the complete derivative of xy with respect to y, now the answer would be, I will first find the derivative of x. Derivative of x is dx by dy, and I will multiply it by y, plus I will multiply x by the derivative of y. Derivative of y is 0. Derivative of y is 1. So this is the answer of full derivative of xy with respect to y. You can see this is the complete derivative of xy with respect to y. This is the complete derivative of xy with respect to x. If I find the partial derivative of the same thing with respect to y, can anyone tell me what will be the partial derivative?
X.
Partial derivative will only be x. So as you can see, partial derivative is quite simpler compared to your complete derivative. That is known as the partial derivative. Do you understand this or this is going above what saying bye bye? I am going. Don't worry about me. Hmm? Do we understand this? Yes or no? Have you written this down? That is the partial derivative. Now, we have seen how force and energy are related to each other. Now, I'll give you a question where we already know the answers, but we will try to find out these answers in a different way. So, this is the question that comes for you. The potential energy of a spring is given by the relation U is equal to half kx square, where x is the extension in the spring. We know that. Find the force associated with this potential energy. So wherever you have potential energy, you will have a force associated with it. Wherever you will have a force which is conservative, you will have an energy associated with it. You have to find out the force associated with this potential energy, and I'll give you 2 minutes to do it. You already know the answer. So, how are you going to do this? Anyone got any answer?
Minus kx, sir.
Yeah, that's great. See, it is very simple, and we already know minus kx. Why minus? Because it is opposite to displacement. Do you remember this? Spring force minus kx. Minus only indicates that it is in the reverse direction of x. So, u is given, and this is a one-dimensional force only as a function of x. It's a one-dimensional force. So, how will I get the value of f? F vector is minus del u by del x into I, because we are writing it vector wise, nothing else. I differentiate it and I will get minus kxi. Everyone got this? Yes or no? Vectorly. Because there is no y and z, so though I don't have to differentiate y, z, and land up with a lot of trouble. Anyone understands this? Chalo. Then we have this one. The potential energy of a particle is given by this. Find out the force associated with this potential energy, and I will give you 2 minutes to solve this. So how are we supposed to get this? Remember, energy is given as x square plus y square. I have to find out the force. Remember, the formula of force is minus del u by del xi plus del u by del y of j plus del u of del z of k. Right? Now remember, there is no k factor here, so you will not get k there. The only thing that you are going to get will be between x and I and j. So I take the minus out. Del u by del x. You have to find out the partial derivative of this with respect to x. So what will you get? I think you will get 2x. Yes or no? 2xi plus you have to find the partial derivative of u with respect to y. And what are you going to get in that? I think you are going to get 2y. So that is the answer, my dear friends. Everyone got this? Yes or no? Can't see you because power had gone, so my thing is gone down. I hope you have understood this concept. That is what my understanding is. I'll give you a minute to note it down. Please note it down. And once you note it down, please tell me, sir, we have done. I can't see you. We do one more question on this. And this is a question number 3 on this. Find out the force for which the potential energy is given by U is minus xy. Again, I can make a energy function which is in x, y, and z. I will make it. Don't worry. Right now, get me the answer for
Y.
this. Yes, you know the answer already. Well done. Tell me the answer then. Yes. Okay. I'll give you a minute to think about it. So, how are you going to do this? Remember, force is negative of du by dx I plus del u by del y of j. And I'm not writing the k1 because I don't need it. So I now need to take the partial derivative of this with respect to x. and that will be minus y. Minus and minus will get cancelled, so force will become y I. And then I have to take the negative derivative with respect to y, and that will be x. So this is going to be the answer for this one. Do we understand this, everyone? Okay. Let me give you one more, and let me make a three-dimensional force so that you have a force three-dimensional in nature. Now I am there, a force which is three-dimensional in nature. So I have the energy function as x square plus 2y plus z cube. Can you find out the force which is associated, the conservative force which is associated with this function? And I'll give you 2 minutes to do it. So what do I have here? Again, I have to find out the force. Let me write the formula first. Force vector minus del u by del x of I plus del u by del y of j plus del u by del x del z of k. I have to find the partial derivative of x, y, and z, partial derivative of u with respect to x, y, and z, and then get the final answer. The force vector would be equal to minus, let me take it out, 2xi plus 2j, derivative of y is 1 with respect to y, plus 3z square k, and that is the answer, my dear friends. Everyone got this, yes or no? So this is how you find out what? This is how you find out force from the energy function. We have already found out energy from the force, but still I will give you one question where you can find out the reverse one as well, so that if there is any doubt, that gets cleared on its own. So this is the next question, question number 5 or 6, whatever the number is. Force is given as, F vector is given as minus 2xi minus 2yj. You have to find out the energy function of this. Find out the energy function of this. This is the conservative force. You have to find out the energy function. You have 2 minutes to get the answer and stay happy. So how are you supposed to do this? Well, I have already told you, if it was given to you from where to where you have find out, you need to find out the potential energy difference. No point is given here. The formula that I gave you was in the point form, between 1 and 2. Between 1 and 2, how do I find it out? I had given you the formula in terms of definite integral. The same formula in terms of indefinite integral will look like this. The same formula in terms of indefinite integral will look like this. The same formula in terms of in terms of indefinite integral will look like this. U will be equal to minus integral of f dot dr plus a constant c. Because I don't know the limits of integration, so it looks like this. Do you understand the difference between the formula on the left hand side and the formula on the right hand side? Formula on the left hand side is a definite integral. I know from where to where I have to find out. I'm not finding out the function actually there. I'm finding out the difference in energies between 2 points. On the right hand side, actually I'm trying to find out the function. Do we understand this? This is maths. Physics has got nothing to do with this. Now take 2 and I move on to this one. So now I write U will be minus of f dot dr plus c. Now when I do f dot dr, Everyone knows what I'm going to get. I've already done this. So this is minus integral of 2x dx plus, because minus I have taken already outside, 2y dy in the bracket. Yes or no? Do you understand what I've written? Yes or no? I just need to integrate it. And there is a minus sign here as well. Sorry. There are two minus signs. One minus sign is outside and one minus sign is inside here. So actually 2 minus becomes a positive. I need to integrate 2x dx. So what is my function? My energy function becomes x square plus y square, the integral. That is my original function, plus a constant c, because I don't know the integration limits. So that becomes my potential energy function. Do we understand this? To get force from potential energy, you take the partial derivative. To get energy from force, you do the integration. We understand this? I'll give you one more. This is a force, which is a conservative force. 2x square I minus yj plus 2k. You have to find out the energy function of this force. And I'll give you 2 minutes. Don't worry about that. 2 minutes you have. Well, no answer till now. Is it such a difficult question? So I have to find out the energy function. So I can write this formula if you are
2x cube by 3 minus y square by 2 plus c, sir.
minus of integral of fx dx. If you want, you can write it like this, plus fy dy plus fz dz, and write it a shortcut formula like this if you are facing troubles in understanding how it is done. So u will be equal to negative sign comes out, integral of 2x square dx. Now you can make them different, plus integral of minus y dy plus integral of 2 dz plus c. So energy becomes integral of 2x square is x cube by 3. Integral of minus y, minus comes out, minus, it becomes y square by 2 plus 2 comes out, integral of z becomes 2z plus c, and that is the answer that we are looking for. Do we understand this, or this has gone above our head saying bye bye, bye bye, bye bye, bye bye, bye bye? Understand this, huh? Yes or no? I'm not seeing raise hand from the boys. Boys, are we there or we have gone to chill out? Okay. Chalo. We move on to the next heading. And the next heading is potential energy curve. What is this potential energy curve? Now, normally we draw this curve for a one-dimensional force, because if it is a three-dimensional force, we will have to draw three different curves, and it becomes quite cumbersome. So whenever this curve comes, that will come only for a one-dimensional force. That curve will only come for a one-dimensional force. Here it is drawn for a one-dimensional force. So you can see it is drawn between ux and x. I mean, the force is only along x. If the force is along x, y, and z, you will have to draw it along x, along y, and along z, three different curves. It becomes too complicated. Doesn't matter. We just have to understand what is happening here. Now, this is the potential energy curve. There are some points which are of great importance here. What are the points which seem very important? Which are the points that seems important? Now, whenever we have this curve, this is a curve, this is a one-dimensional force. The first thing that you must understand from this curve, that if you find out the slope of this curve, what will you give? What will it give you if I find out the slope of this curve? What will I get from the slope of this curve? This is the curve of potential energy. From the slope of this curve, what will I get? Huh? I can write it as minus du by dx because it is only along x. So partial derivative or complete derivative does not make any difference here. It is same. If you find out the derivative of this, or the negative derivative of this slope, negative slope of this curve, negative slope of ux curve, that will give us what? That will give us what? You understand the meaning of derivative? Derivative means the slope of the curve. Do you understand this? Yes or no? Force is the negative derivative of this curve. Therefore, force is the negative slope of this curve. Do we understand this? Yes or no? Everyone understands this? I am not getting any answers. Do you understand this?
Yes,
Force is
sir.
the negative derivative of this curve, and therefore force is the negative slope of this curve. Negative of the slope is force. We understand this? Okay. Now there are certain points which are of great importance. Point B, point C, point D, and point E. What is so important about these points? What is important about these points? B, C, E, and D. What is important about these points? What is important about these points? At this point, slope is, what is the slope? Slope is 0. The curve becomes flat. Slope is 0. At the same point, at the same time, at these 2 points also, slope is 0. Do we understand this? Or this has gone above our head saying bye bye? Bye bye, sir. I'm going bye bye. Do we understand this? Huh? Slope is 0 means what? Slope 0 means what? This is the potential energy curve. Slope 0 means what? Huh?
Force is 0, sir.
What exists? Force is zero. Good. Force is zero. Force is zero means what? Eh? Force zero means what?
Zero means what? Done zero.
Okay, work done is zero. The body is in equilibrium. The body is in equilibrium. Do we understand this? Yes or no? Or it has gone above our head saying bye bye? Bye bye, sir. Bye bye. I'm going bye bye. Bye bye. Huh? There's a difference between point C, D and point B and E. That's why B and E are written with green and C and D are written with pink. All these, all the things up till now I have written are same. But I have painted, and I'm not a very good painter, painted B and E as green and painted C and D as pink. Why? Sir, you like whatever color you put. What do I do? What do I know? Huh? Why did I paint 2 points differently and the other 2 points differently? Just because they were looking good? Or I want to make the national flag of India, Tiranga? One pink and not kesaria, one pink and one green, and in between there was white. So I was trying to paint Tiranga and show you. Look, you see, I'm so patriotic. You know, even in teaching physics, I get the Tiranga in between. No, that was not the reason. I was not trying to paint the tricolor. Yes, what was the reason? Huh? Sir, we don't know.
Minima and maxima, sir.
At green points, we have potential energy minimum. U is minimum. Potential energy. It's the graph of potential energy. And X, U is minimum. I hope everyone is writing it. And at this point, U is maximum. And at this point, U is maximum. Now, if you now these days it is the football season. Argentina and France are going to play the World Cup, and I'm vouching for Messi to win it. No, if I have a football here, why I want to play football right now? If I have a football here, oh, black color football would be better. Hey God. If I had a football here at this point, and if I kick it, it is in the valley. If I kick it slightly this side or slightly this side, what will happen? The football will what? If I kick it slightly,
Again, football comes the same point.
it will come back to the same point. Ding, ding. It will come back. Football. I do the same thing here. I go to the next valley and I try to put the football up this side or this side. What will happen?
Can come back.
It will again come back. We are playing football. Everyone loves football. Still, we cannot make a good enough team to even win an Asian championship. Okay, it comes back. I now go on the top of the hill with my football. Oh, I love football. I know nothing about it. I was a captain of the college team. That is a different aspect altogether. I know nothing about it. Okay, point C. Now take my football on the top, and now I give it a slight push. Ding. What happens? Ding. What happens? It never comes back to point C. It just goes down. Sir, why are we playing football? This is supposed to be a class of physics and not a football. We are playing football because we are trying to understand something here. At point B and E, if there's a football or if there's a body, if I try to push it up, it will come down. It tends to come down to the point B and E from no matter where I throw it. We always try to come down either to point B or point E. Everything wants stability. Ronaldo wants stability. He's moving from one club to other. Everyone wants to be stable. Everyone wants to come to a state of stability. But stability means less energy, less money. If you stay in a company for long, you will be stable in that company, but you will be earning very less money. Less money, less energy, but more stability. More money, no stability. One day you will be thrown out of the organization. This happens in the coaching industry. People go from one coaching to other, and they get a lot of package, and next day, 2 months later, they're thrown out because they're in a state where they're at the maximum energy. Maximum energy means least stability. Point B and point E are known as the stable equilibrium. And that is what you need to understand. Point B and point E are known as point of stable equilibrium. Minimum energy, maximum stability. You stay in one organization for long, you may not earn that much, but you will remain stable. Maximum stability. Minimum energy, maximum stability. You jump from one to another, you learn a lot of money, but you will not be stable. So this is known as unstable equilibrium. You are in equilibrium, but you are in unstable equilibrium. Any day, you will be thrown out of the company because you are taking too much from that company. Do we understand this? So this is gone above our head saying bye-bye. Bye-bye. So if you want to be stable, take the minimum energy level. No one will move you from there because if they try to move you, you'll always come back. You'll always come back. I'll give you 2 minutes to note it down.
Done, sir.
Done, sir. Well done, sir. Congratulations, sir. Do you understand stability and instability? One more graph to wind it up. And I hope you understand what is meant by this graph. Force is the negative slope of potential energy. Slope. Slope. Force is the negative slope of potential energy. Force is the negative slope of potential energy. Where the slope of potential energy is positive, force is negative. When the slope is negative, force is positive. And it is shown in this graph. And we'll be discussing this graph in the next class, since the time of the class is already over. This is the best possible graph in the entire universe that can make you understand what is happening here. So we draw the graph and we shall proceed from this point onwards in the next class. We are dealing with a very, very sensitive topic, and that is potential energy. Energy and force, stability, and all these things, sensitive topics, and we will dealing with these sensitive topics in the next class, my dear friends. I hope you have understood what we have done today. Huh? We have understood what we have done today. We have noted it down, yes or no?
Sir.
Well done, and I'll see you in the next class. Take care, and may God bless all of you. Bye bye, beta.
Thank you, sir.
You have understood what we have done today. Take care.